Hello friends, good afternoon everyone. I am fine. How are you? I hope you will be fine. Welcome back in my channel, Dr.Satendra. Dear friends, if you want this type of videos relative to mathematics for higher level, then you need subscribe, share and like my videos and my channel. Today we will discuss short type questions based on ordinary differential equation of higher order. Now, first question. Solve d2y upon dx2 minus 3dy dx plus 2y equal e to the power 3x. Now for CF, d square minus 3d plus 2y equal to 0. Auxiliary equation, by putting d equal to m, we get m square minus 3m plus 2, this is equal to 0. Now factorize this. M minus 2, m minus 1, this is equal to 0. Now root of the equation 1 comma 2. Then complementary function can be written as c1 e to the power x plus c2 e to the power 2x. Since both roots are different, we have c1 and c2 are arbitrary constant. Now remaining part, that is particular integration, can be written as e to the power 3x upon d square minus 3d plus 2. We simplify this, e to the power 3x upon d minus 1 d plus d minus 2. Now the method of e to the power ax pi, put d equal to a. D equal to a is the coefficient of x, that is 3. Now again repeat, method of e to the power ax is by putting d is equal to a, where a is the coefficient of x, that is 3 here. Now e to the power 3x upon 3 minus 1, 3 minus 2. E to the power 3x upon 2 into 1, this is equal to e to the power 3x upon 2. Now complete solution is y equals cf plus pi, that is c1 e to the power x plus c2 e to the power 2x plus e to the power 3x upon 2. Now next problem, find pi of d cube minus d y, this is equivalent to e to the power x plus e to the power minus x. Solution. Now pi equal to e to the power x plus e to the power minus x upon d cube minus d. There are two problems, can be written as e to the power x upon d into d plus 1 d minus 1 plus e to the power minus x d into d plus 1 d minus 1. We take d common, then we get d square minus 1. Factorize this, d plus 1 d minus 1. Now method of e to the power x, d equal to a. Now e to the power x 1 into 1 plus 1, where a is equal to coefficient of, that is 1. Now by putting d is equal to 1 in this, then we get 0. So accept this, we put d is equal to a. Now d minus 1 as it, plus here in the second term, by putting d is equal to a, where a is equal to minus 1. e to the power minus x minus 1 minus 1 minus 1. Put in this d is equal to minus 1. Here we put d is equal to minus 1, we get 0. It is not possible. To separate this d plus 1 as it, and by putting d is equal to minus a in and in. Therefore d to the power x to d minus 1 plus e to the power minus x upon minus minus plus 2d plus 1. Now d equal to d plus a. When by putting d is equal to a, we get 0 in denominator, then method is changed, d is equal to d plus a, where a is equal to 1 and where a is equal to minus 1. Now e to the power x to d plus 1 minus 1 plus e to the power minus x to d minus 1 plus 1. 1 this cancels this is cancelled this. Then we get e to the power x upon 2d plus e to the power minus x upon 2d. Therefore, e to the power x upon 2 as it, and 1 upon d integrate 1, that is x. Similarly here, e to the power minus x upon 2 x. Now x by 2 common, e to the power x plus e to the power minus x is a pi of problem. Now next question number 3. Find the pi of d2y upon dx2 plus dy dx equal x square plus 2x plus 4. Now answer pi equal to, there are 3 questions. X square upon d into d plus 1 plus 2x upon d into d plus 1 plus 4 e to the power 0 d into d plus 1. Now in the last term we put d is equal to a where a is equal to 0. Now we solve first and second term by binomial. 1 upon d as it, 1 plus d whole power minus 1 x square. Similarly here 2 upon d, 1 plus d whole power minus 1 x plus 4 e to the power 0x upon d 0 plus 1. Now here 1 upon d expand binomially. We know that the formula of binomial 1 plus x whole power minus 1 is equal to 1 minus x plus x square minus x cube plus up to dot infinity terms in this. Similarly 1 minus x whole power minus 1, 1 plus x square plus x cube plus up to dot, here will be infinity terms. Now 1 minus d plus d square plus minus up to dot x square plus 2 upon d, 1 minus d plus up to dot x plus 4 upon d. Now e to the power 0 x is equal to 1. This is equal to 1 upon 2 x square as it. Now differentiate of this is equal to 2x. Now d square operate x square, we get 2 and higher order will be 0 plus 2 upon d as it. Now 1 into x and d into x, we get 1 plus 4. Now d integrate 1, that is we get x. Now d, now integrate above 1 upon 2 as it, 1 upon d, sorry, 1 upon d, 1 upon d as it. Now we get integrate x cube upon 3 minus x square plus 2x plus 2 x square upon 2 minus x plus 4x. This is equivalent to minus x square plus x square, cancel this. Minus 2x plus 2x cancel by. Then we get complete solution, that is pi of question x cube upon 3 plus 4x. Okay student. Now next problem, question number 4. Solve x dy minus y dx, this is equal to 0. Now answer, x dy equal to y dx on variable separable, variable separable, dy upon y equal to dx upon x. Then integrate, we get log y equal to log x plus log c1, where c1 is arbitrary constant. This is equal to log c1x. Now we get y is equal to c1 is a solution. Now next question, question number 5. A condenser of capacity C is charged through an inductance L and resistance capital R in series, where charge Q satisfies the equation L d2q upon dt2 plus A dq upon dt plus bq equal to 0. Please stop here. Find A and B. This is important question. A condenser of capacity C is charged through an inductance L and resistance R in a series, where charge Q satisfy the equation L d2q upon dt2 plus A dq upon dt plus bq equal to 0. Here we find value A and B. This is the standard equation. We know that standard form of equation, when LCR in series L dq upon dt2 plus R dq upon dt plus q upon c equal to 0. Now comparing the standard equation of given equation, then we get by comparing given equation with standard form equation, we get capital A equal to R and capital B is equal to 1 upon C. Now next question number 6. Find the particular integral pi, that is particular integral of equation d minus a whole square y equal e to the power ax f double dash x, where double dash denote differentiate with respect to x 2 times. Now answer pi equal particular integral e to the power ax f double dash x upon d minus a whole square. E to the power x multiplied any terms. First we calculate pi of e to the power x by putting d equal to d plus a, e to the power ax as it, f double dash x upon d plus a minus a whole square. This cancel by this. This is equal to e to the power ax f double dash x upon d square. Now d square operate only f double dash x, that is it wants integrate 2 times. Now we get f e to the power ax integrate 1 times to omit 1 derivative and integrate next time omit second derivative, that is we get fx. This is the solution. Now next question number 7. Find the root of the auxiliary equation, that is A, auxiliary equation of the differential equation d2y upon dx2 minus 6 dy upon dx plus 9y is equal to 4 e to the power 2x has been come AKTU 2016. Now answer. Here only put up auxiliary equation, root of auxiliary equation. Now for CF, d square minus 6d plus 9 y equal 0. Now auxiliary equation, by putting d is equal to m, we get auxiliary equation m square 6m plus 9 equal to 0. This is the m minus 3 whole square. Now m is equal to 3, 3 are the roots of auxiliary equation of given differential equation. Now next question number 8. Question number 8. Find the CF of the differential equation x square y double dash plus x y dash minus y equal to 0. That is, we can write x square d square plus x d minus 1 y equal to 0. This is the Cauchy-Euler equation or homogeneous linear differential equation. This is Cauchy-linear equation. Euler-Cauchy equation or other name is homogeneous linear differential equation. Now, auxiliary equation can be written as d minus 1 plus d only minus 1 as it. This is equal to 0. Now d square minus d plus d minus 1. This is equal to 0. Now d equal to plus minus 1. Since z equal to log x is a solution, since z equal log x is a solution of homogeneous linear differential equation or Euler-Cauchy equation. Now CF can be written as C1 e to the power minus z plus C2 e to the power z, where C1 and C2 are arbitrary constant. Now putting the value of z log x, C1 e to the power log x plus C2 e to the power log x. Now C1 upon x plus C2 into x is a CF part of equation. Now next question, question number 9. Find the pi of d square minus 2d plus 1 y equals sin x. Has been come MTU B Pharma 2011. Now answer, pi sin x upon d square minus 2d plus 1. We know that the pi of sin ax or cos ax, d square equal to minus a square. D square equal minus a square, where a is equal to 1. A square, यानी कि 1 square 1 minus 1. Now we get sin x upon minus 1 2d plus 1. This cancel by this. This is equal to sin x upon minus 2d. Now d integrate sin x. Minus 1 upon 2 cos x upon minus 1. This is equal to cos x upon 2 is a pi of given equation. Now next question, question number 10. Solve d2y dx2 minus 2 dy dx plus y equal to 0. Answer, for CF d square minus 2d plus 1 y equal to 0. Now we can write auxiliary equation by putting d equal to m square minus 2m plus 1 equal to 0. That is m minus 1 whole square equal to 0. Now m is equal to 1 comma 1. then we can write CF equal to C1 plus C2x e to the power x. Now solution or complete solution or general solution can be written as y equal to CF only, that is y equals C1 plus C2x e to the power x. This is a complete solution or general solution. Now next question. Question number 11. Form a differential equation. Form a differential equation whose general solution is y equal e to the power minus x c1 cos under root 3x plus c2 sin under root 3x plus c3 e to the power 2x. Now answer. We get here this is given y is equal to e to the power minus x into c1 cos under root 3x plus c2 sin under root 3x. This is the root of equation due to general solution can be written this, that is CF part of the solution due to the complex root whose value minus 1 plus minus I under root 3. Since y is equal to e to the power minus x c1 cos under root 3x plus c2 sin under root 3x. This is the CF part. Write down due to the complex root whose value minus 1 plus minus under root 3i plus c3 e to the power 2x. This is the other CF part which is written by due to the d is equal to 2. Now we can write auxiliary equation of first part can be written as m square plus 2m plus 4. Solving this part, we get value of m minus 1 plus minus under root 3i. Similarly, auxiliary equation of second part is equal to m minus 2. Now complete auxiliary equation equal to m square plus 2m plus 4 into m minus 2. This is equal to factor of m cube minus 8. This is the factor of m cube minus 8. Now we can write differential equation, that is differential equation will be d cube y upon dx cube minus 8y. This is equal to 0. Okay student, this is the complete